Hello everyone, and welcome to another episode of the show about science. This is your host Nate, and today we will be talking about what is going on inside of your dog's mind. It's going to be a great episode, so let's go barking right into it. So, I recently adopted 2 dogs, Penny and Angel. And I wanted to know what in the world these dogs think about all day. And if you have pets, you probably wonder what they're thinking about too. Which brings us to today's guest.
So I'm a neuroscientist, which means that I study various parts of the brain and the nervous system. And I'm a professor at Emory University in Atlanta, Georgia.
This is Gregory Berns, and for most of his career, he's been working with brain imaging technologies.
And that means things like magnetic resonance imaging, or it's just abbreviated MRI. And we use that to look into people's brains to figure out how our brains work. And then about 10 years ago, I switched from doing that with people to trying to figure out how dogs think. And so I began training dogs to go in MRI scanners so I could figure out how their minds work.
And to clarify about the dogs going through the MRI, could you actually see what's going through their heads, like the words, if there are any words? Or could you just see which parts of the brain are active?
That's a very good question, and it's oftentimes very difficult to figure it out because we don't really even know in a human brain what all the patterns of activity mean. So when we're doing an experiment, whether it's a person or a dog, what we try to do is set up what we call control conditions. So we make the experiment as simple as possible. And then what we do is we look for changes in activity, things that either increase or decrease in different parts of the brain. And then what we do is we try to figure out how the dog's brain is different, say, from a human's brain. So it's not the case that we can actually see literally what a dog is thinking because we're trying to, I guess you would call it, reverse engineer or work backwards to try to understand how their brains are put together and what that means.
How did you train the dogs to go into the MRI?
Great question. So we started very slowly and we used lots of treats. And because a dog has never seen an MRI scanner, they have neither good nor bad impressions of it. So the way we approached it was we built a simulator of an MRI, which looked like just a big tube lying on its side. And we built mock-ups of what's called the head coil. And the head coil is something that surrounds the dog's head. It's the same part that we use in humans that allows us to pick up the signals that come out of the brain during the MRI process.
And bonus, it helps them not have to hear the noise of the MRI.
That's right. So unless you've had an MRI, you probably don't know, but they're extremely loud. They sound a bit like a jackhammer, someone jackhammering up concrete, really.
For everyone listening out there, it sounds a little something like this.
And so the whole process for the dog is we do it very slowly over periods of weeks to months, and we introduce different elements one at a time. So we might start with a dog in this mock-up of the head coil, just training on the floor. Sorry, that's my dog scratching. And then once they get good at that, then we might move it into the tube. Then we might have them walk up steps to go into the tube. And then when they're really getting comfortable with it, then we'll introduce recordings of the MRI noise, which we've taken, and we start at low volume. And the idea is we try to make it a game for the dogs. So it's all fun, and we use lots of treats so that when they get to the real MRI, it's just another activity that they do with their owners.
And you incorporated some visual signs, like raising a hand meant there's going to be a treat, putting hands together meant there's going to be no treat. So what parts of the brain lit up when you did those signs?
Right. So the very first experiments that we did was exactly as you described. And the idea was to see what parts of what we call the reward system are active. So we know in all brains, particularly brains of mammals, including us, that there's a particular set of structures that are very active when an individual is expecting something that they like or something that they're very interested in. And so when we taught the dogs that one hand signal meant you'll get a treat and another hand signal meant nothing, what we saw was, in fact, that yes, their reward systems became more active when they saw this hand signal. And so really what that shows is primarily that the technique works, that you can actually do this, that the dogs will train to hold still enough for the MRIs, and that we can get data from the MRI that we can interpret and that it makes sense. And that lays the foundation for more complicated experiments and things that probably are more interesting to people, like, does your dog love you, for example?
Yeah, how do you know if your dog loves you?
Yeah, well, that's a good question. How do you know if a person loves you, right? Usually you ask the person, but we can't do that with the dogs.
Right.
So we either have to interpret their behavior or we do like we've been doing and we go directly in their brain to try to see if their reward systems are more active when they see their person and their person is not giving them food. Maybe they just pop into view and say, good dog. And in fact, when we did do those experiments, we found that the reward systems are indeed very active just to the presence of the person, just saying the dog's name and good girl. And we think that that means that dogs have what we call social reward, that they value that contact just as much as we do.
Is that the same in humans? Like if a human that they love walks into the room, will the same parts of the brain light up?
In fact, they do. And that was the inspiration of the experiment that we just described with the dogs. So yes, that's been done with humans, and it seems quite robust.
So, did you branch out like the signs with there's going to be a treat and there's not going to be a treat to like other signs like, oh, you were a bad girl, you were a good girl, stuff like that?
Yeah, we've done, I've lost track of how many experiments we've done over the years, but the ones I just described are probably the simplest ones and the ones that we started with. So we've done experiments looking at their sense of smell. We've done several experiments. So kind of along these lines of social signals, we did an experiment where we collected the scent of humans, the dog's human, so their owner, as well as other people in the household. And when I say collected their scent, what we did was we had the people wipe cotton pads under their arms so they get a sweat sample. And then we would present that to the dogs in the scanner. And then we would also present the smell of people that they've never met before, so complete strangers.
Ooh.
And then we also did something similar where we collected the scent of other dogs, including dogs in the household, as well as strange dogs. And what was interesting when we did that, again, the same set of structures, these reward system structures, were most active when the dogs smelled their human, their owner, not a strange person, not even another dog in the household.
Oh. So what did light up when they sniffed a stranger's smell?
Not very much apart from just the smell center of the brain, but that just becomes active when they smell anything.
True.
So what was critical was the reward system, what activated that the most.
I see. An interesting experiment would be if you show them the smell of the stranger multiple times in private, not around the MRI, and then did one before they had ever smelled the person before and then one after and see what changed. That'd be interesting. Now I'm just giving you ideas.
That's a great idea. That's, for example, would they learn the association or would we see evidence that it's like, hey, I recognize that smell? I don't know. But one of the ones that we've done recently is we've been trying to understand how dogs process human speech. So we talk to the dogs as if sometimes that they're people. We know that they're not, but that doesn't stop us from talking to them like they're a person. And so the question is, how much human language do they actually understand? And then what does that look like in their brain? So to give you an example, if I say the word car, you can call up in your mind a picture or an image of a car. You might even call up kind of a sound of a car. You have many different ways of what we call representing what a car is in your brain. And the word itself is what we call a placeholder, or just an abstract label for an actual thing in the world, what we know as a car. So the question we had was, well, if we say that to a dog, do they have similar representations in their brain? Or is it more like the hand signal experiment where it's just what we call a stimulus response? They hear a sound, the word to us car, but that doesn't have any meaning to them, but it just triggers some kind of response in their brain. So we did an experiment about a year or two ago where we taught the dogs names of toys, 2 toys actually. And it actually took a long time. It actually took about 6 months for most of the dogs to learn the names of 2 toys. It turned out to be more difficult than we expected. But once they did that, then we brought them to the scanner and we had the owner speak the names of these toys to the dogs. And what we were looking for was evidence that perhaps in their visual parts of the brain, were they calling up images of these objects like humans do. So that often happens when you do that experiment with humans. But in fact, that's not what we found. In fact, we found as a control condition, we also had the owners speak gibberish, just nonsense words. And normally when you do that with humans, we just kind of turn it off after a while because we recognize that there's no meaning to them. But in fact, we found the opposite in the dogs, where the auditory or the sound part of the brain seemed more responsive to gibberish than actual words.
You have failed us, dogs.
Well, I think what it's telling us is that, dogs try very hard to understand what we're communicating with them. And when they hear things that they haven't heard before, to them, that's a signal that the human is communicating potentially something important, but they don't know what it means. And so they pay more attention to it. But it also shows that their brains are not as complicated as a human brain to the point that they have actual language structures, because obviously they don't speak, they don't have actual language like we do. And so it's probably unreasonable to expect them to really understand meaning in words like we do. It's probably best to just speak simply to them.
What can science teach dog owners to make them better dog owners?
Yeah, I think we've learned so much in doing these brain imaging experiments. The experiment on communication, on language that I just told you about, tells us that we have to be very careful when we're communicating with the dogs. If, for example, if we want a dog to do something, say come, or even sit, and sometimes they don't do it, we humans can get very frustrated at the dog. And, sometimes people think, well, the dog is just being stubborn. Well, they may be, but maybe they just don't understand. So what we're finding is that their communication systems are different than ours. And so when we're trying to communicate with the dog, we have to understand how the dog is processing what we're saying. And it may not be like we think it is. And so by studying these brain responses, that gives us insight into how perhaps better to communicate with the dogs. So we actually did an experiment on this, which was a variation of the hand signal experiment. So we looked at how quickly or how efficiently the reward system learned associations to a treat, whether it was a spoken word, whether it was a visual cue, or whether it was a smell. And what we found was that the visual cue and the smell were both equally efficient at activating the reward system, but the words took the longest. They were the slowest to adapt to that. And so it just points out that even though humans like to use speech and language to communicate our wishes, we're the only animal that does that. No other animal really has a communication system like that. And so if we want to better interact with our dogs, then we need to be more attuned to ways that they're used to.
I think my dogs would agree with you on that. Gregory, if people want to find out more about your work, then where should they go?
Well, you can go to my website, which is gregoryberns.com, which has links to all of our research as well as the books that I've written. You can follow me on Twitter, which is gberns, or on Instagram at The Dog Project.
All right. Well, thank you for being on the show.
Oh, my pleasure.
There you have it, folks. The show about science is complete. Music on today's episode comes from Epidemic Sound, and our theme song was composed by Jeff Dan and Teresa Brooks. Okay, Dad, you can shut the recording off.